Hello, I'm Duncan, and I'll be talking today about responding to cyber attack at machine speed. This is a Prezi. You can access it online. If you go to a post I put out last night on Peerless, you can find a link to the talk and get slides ahead of me if you want. And also, if you ask your questions there for me to answer at the end, there's a chance you'll win a Barnes & Noble gift card. Standard disclaimer that everything I'll be discussing will be my own views, my own perceptions, and do not represent my clients, employers, or any of the organizations or companies that I'll be talking about. Quick pop quiz. Everybody in the room who was born in 1977 or later, so you're 40 or younger, please raise your hand. Okay, I'm old. I graduated college before all of you were born. Cyber's been in the news a lot lately. Not in a good way. Our days are stolen, finances getting hacked, and unfortunately now physical things are happening as well. The cyber physical world is being hacked. And all this is very scary, creates fear, uncertainty, and doubt, but unfortunately that's all pretty much water off a duck and hasn't really impacted much. Any Jerry Maguire fans out there? So one of the other areas that makes a difference is the monetary, and I'll be discussing some of the monetary aspects of things I'll be talking about later, and there is a lot of money to play with. Prediction is that we'll be spending $1 trillion on cybersecurity in the next 5 years. $1 trillion is a really big number. You can take a tenth of 1% of $1 trillion and you still have $1 billion. But that's not the only problem. The other problem is there aren't enough of us. There aren't enough people in cybersecurity. We're currently down to about 1 million people, and they expect that number to grow. So why are we spending all that money? What's needed here? Another way to look at it is through the risk lens. We're spending that money to reduce the risk of loss and safety issues, and there's different ways of looking at risk, and I highly recommend the methods proposed in this particular book. In fact, you can use your Barnes & Noble gift card when you win it to buy this book if you like. I'd hand them out, but I didn't want to carry all copies. Plus, let you buy your own book. So that $1 billion number was basically a trend extrapolating current trends, but if you think of that as a pot to play with and then apply the measures in this book, I think things will get better. But what's the actual problems we're trying to solve? This is a chart from the Verizon Data Breach Incident Report of a couple of years ago. The current data is even better to make my point, but this graphic I really like this graphic. It's very pithy. And what it's basically saying is the attackers are winning the automation race over the defenders, and I want to talk about some things to change that. So let's dive into a little more detail, but first let's look at basically what the hacker's trying to do. If you plot what the hacker's trying to do on a 4-dimensional plot, basically they're trying to penetrate. Y-axis is they're going to escalate and move laterally. Z-axis is they're going to exfiltrate, and then the 4th dimension is they want to persist. This is Salvador Dali's The Persistence of Memory to show the time dimension. Now, how are they able to do all this through all these talks through the rest of the day? But they're doing this because the software is very vulnerable. We live in a glass house made of software that has bugs in it. And my talk is not going to be how to solve that upper row and make there be less bugs, but I can never resist at least giving some advice in that area. So I do recommend all software developers or people who control software developers look very closely at the rugged manifesto, that's the Agile manifesto, but this is for secure DevOps. And I recognize that my code will be attacked by talented and persistent adversaries. Just take that into account. Now, mentioned before that hackers are now affecting the physical world as well, and an organization that's looking to try and improve things in that area that I highly recommend is I Am the Cavalry, particularly in safety critical applications. So, conclude that we got to improve the software quality. if we want to reduce make it harder up at the upper level, or put better incentives in place to deter them. But I'm going to mainly be focusing on trying to take that bottom layer and moving it to the left. And let's look at what the issues are there, because basically what we need to do is we need to detect that they're in there, and then we need to respond to them. So we buy millions of dollars a year already of security gear, and it generates a lot of data. And what does that data create? It creates work for us for humans to go do things. You have to turn that data into actionable alerts. And one of the big issues is the actions need to be taken by humans. And humans don't scale all that well, particularly with large volumes. All the SOCs I've ever worked with do prioritize their actionable alerts and never get to the bottom of the list, basically, due to their limits if there's just not enough time for the people involved. And it's too hard for them to do it. And that also results in alert fatigue. There's just too much going on there, because humans don't do the repetitive tasks all that well, and they get depressed. So a group of people got together and came up with this concept of the integrated active cyber defense, where you want to try and take the human out of the loop and put them on the loop, do the things that humans do best. One of their goals is product agnostic interoperability, because a lot of the issues are associated with the breakage between the proprietary interfaces, and you got to put a human in between those interfaces, because they don't talk to each other. And the way they do accomplish this is by decoupling the functions and standardizing the interfaces. Now, when we say decoupling the functions, what are we talking about? We're talking about the creation of all this data that we talked about, where the sensors do the sensing, okay, and then you have to make sense of it, sense making, which is the data correlation, artificial intelligence falls into that category, etc. Once you know what's going on, then you need to make a decision about it, and then you have to go do something. I'm going to spend most of my time talking about the doing something, where work is going on there. But before I do that, on this in the loop to on the loop concept, at RSA, a speaker used a great phrase, so I had to make a view graph of it, because basically the attack team's operating at the speed of light to the defense team's operating at the speed of lawyers. Now, it is true that you do need to have your legal team involved, but one of those aspects, even in the decision-making piece of the loop, is you have to make playbooks ahead of time, get your legal team involved, and to approve actions you can take under what conditions, and do all that a priority. If you're doing it at the time of the attack, it's already too late. So, apologize for the very complex view graph, but the IACD community gets together and has a community day every so often. There was one about a month ago. I lifted this view graph from one of the talks there, and it's by Johns Hopkins University. The Applied Physics Lab is doing work in this area, and they took a bunch of prototype implementation, so early stages, of companies that are working in this IACD area, and they put them in their actual university environment and did a sort of before and after. And I'd like to highlight three particular points here. I'll zoom in on them a little bit so you can see them. The first is there was a 5 order of magnitude increase in triage capability. In other words, computers scale better than humans. Second, there were 2 orders of magnitude increase in what's called the indicator to mitigation completed action. In other words, because it's now a computer in the loop instead of a human in the loop, you can get to some of those actions that you were ignoring earlier. And the most important one in my mind, even though it's from actual numbers viewpoint, the smallest of the 3 numbers, but it's still a 2 orders of magnitude improvement in the amount of time that it took to detect. In other words, the shifting of that the chart to the left that we mentioned earlier. And I think it's these numbers that you're going to plug into that risk equations from that book that I mentioned earlier, and do the justification for your security spend. And I think it's going to actually make that $1 trillion a smaller number, because the people who do all this stuff are going to be the ones that take over the market. So how do we get those gains? We get them through automation. And let's take those four categories we talked about. And again, I'm going to focus on acting, but spend just 1 minute more on a couple of the upper parts. I was involved years ago in setting up some standardization up in the upper blocks here, things called Sticks and Taxi, which is the sharing of automation and sharing of threat intelligence between organizations. It's going well, maybe not as well as it could, because of two issues. One issue is it's running into that speed of lawyers I mentioned earlier. You're crossing trust boundaries, and there's not really the economic driver that needs to be there for that sharing after the fact, as well as, well, you just added more lists into those alert fatigues, and there's nothing you can do about it anyway. So there's the second problem is something we hopefully can help with by speeding up the acting area, which is where we're working on OpenC2, which the first baby step is addressing a particular problem I'll talk about here. So if you look at today's environment, configuration of security stuff is very static. And it's static in the sense that it's designed to be provisioned at human or slower speeds. Provisioning speeds is actually usually considered slower than humans. And it's static in the sense of you're going to leave it in whatever way you're doing it for a long time period. You're doing all these bulk file things to do it. You sort of set your system up and leave it alone. We want to change that, and there is a lot of work going on in APIs and stuff, so that'll be better. But even the APIs don't work that great because of this whole proprietary interface. Every vendor has its own way of doing things. They don't interoperate. There's breakage as you switch between things, and so humans have to get in the loop, and that slows everything down. They not only they have different syntax and semantics, they don't even use the same vocabulary. Is it a block, a deny, a stop, a reject, a blacklist? All of those exist. So in this particular area, an industry group got together, OpenC2.org got formed by a bunch of vendors and a bunch of users, and came up with the standard I'm going to talk about a little bit, or came up with hey, I think we should do it this particular way, and then we think, hey, it should be a standard, so it's now moving into OASIS, and a new OpenC2 technical committee is in the process of being formed. So why do I think this will get accepted? Well, those numbers I talked about before, I think, are going to drive the economics, which is what I think will really be the biggest play. But a lot of the work going on in it is by the government, because they're looking at, the actual military is looking at, hey, this is our what we want to do when we get attacked. We got to attack back, so they have these automated playbooks. Commercials interested a little bit in hacking back and can't go quite as far as the military can go. There's a good report on that put out by the George Washington University Center for Cybersecurity. I'd recommend reading. I'll give a graph of it later. But again, I think the main driver is going to be the commercial space, and money is what's going to drive it. And the reason you're going to make that money is because you're going to remove that vendor proprietary interfaces, the vendor lock-in. Vendor lock-in costs a company a lot more than people realize. But the more important one is going to be you'll be able to scale your security in real time. So just like if I'm in my Google Mail and I type, hey, I want a vacation in Hawaii, then this little ad pops up on the side because Google's reading my mail and it's putting out for bid in real time, and the ad that is most relevant, that will pay the most money, is what shows up. You can do that same thing with your security spend. You can accordion it up and down. You can be flexible as to which security technologies you use, and you can do all of that in real time. And that's where I think the real gains are going to be, because you'll plug those value equations from that cybersecurity risk book are going to be what gets implemented to run those real-time algorithms. So there are a number of companies involved, actually a much larger list than this number of companies involved. These are the list of the different security technologies that were used in that IAC Community days approximately a month ago, to just either by these vendors themselves or by people who put shims around the vendors to give them OpenC2 interfaces. but all said and done, it isn't going to be the vendors that drive the market. It's going to be the people who use it involved in this organization are both the civilian and DoD side of the federal government, an extremely large purchasing agent. The financial community is very involved in this. The ISAC is very interested in requiring all banks to do this kind of stuff because it's showing these gains. And there's carriers and other large purchasers like AT&T involved. So now let's talk about OpenC2 itself. Go a little bit into not into a lot of gory detail on the internal techniques. You can look at openc2.org to do it, or you can go to GitHub. There's both the information about the standard itself, but also some open source implementations. But the lexicon tries to decouple the different parts of the command to try and we've made it as flexible as possible, because we probably didn't get it perfectly right the first time, and there's going to be evolution in the security technology. So we think the language is going to have to evolve, and we think we've done this with a way that'll be minimal impact. It's basically easiest to understand this stuff by example. So in red is what it is you want to do, the action. There's 30-something verbs of things that you can do, of which this particular example is deny. Shown in blue is what you want, what's the target. In this particular case, it's a particular IP. It could be a whole 5-tuple. I just didn't type it all in. The thing that's actually going to do the command is called the actuator. In this case, it's a particular network firewall in New Jersey. And then there's some what are called modifiers, some command generic stuff like, hey, I want a response back, and so I can tell them apart. Here's its ID. Here's another example, a little bit higher level command called mitigate, which is used when, say, one bank in the FSISAC wants to tell another bank about a particular problem and what they should do about it, but they don't know the other bank's network, and the other bank's not going to trust them by giving them all those gory details. It's more, hey, no, you want to mitigate this this domain name. Another example is those two previous examples were more sort of networky, high-level based. This one is a more specific endpoint. Hey, go delete a file base. It's particular charges by semantic from that community days I mentioned a couple days ago. But the next use case, the one I like the best, there's a series of these, but I won't show the one, and I'm not going to go into detail. But what's shown in red are all the different OpenC2 commands, a bunch of different technologies that Johns Hopkins used to do that study that got all those huge gains that I mentioned earlier. So this is very complex scenario that no human is involved in, and it actually mitigates a web drive-by. So really impressive stuff. So in conclusion, hopefully I've discussed a little bit the problem that we're trying to address and the problems that it doesn't address. A little bit about what OpenC2 is, the fact that it's moving into OASIS, and now let's end up with just a couple slides on, hey, what are your takeaways? What can you guys all do to help? First off, you can read this information I talked about, this book by Hubbard on cybersecurity risk, I highly recommend, or this report by George Washington University on what companies can do in the active measure space. Software developers in the room, or people who control software developers in the room, please look hard at the Rugged Manifesto. If you want to get involved in the safety debate in software, I highly recommend everybody look at the work of I Am the Cavalry and get involved and volunteer there. But what's really going to drive the adoption of these technologies is the money behind it, and I think that's going to really lead to a big increase in OpenC2. So if you're involved in any way in creating security technologies, please implement this interface. If you're involved in purchasing security technologies, please require that your vendors use this interface. And of course, you can go ahead and help with the work itself in OASIS. And finally, I'm going to end with some words of Dan Geer, one of the thought leaders in cybersecurity. There's never enough time. Thank you for yours.